Thank you, everyone, for coming. I want to introduce everyone today to a new type of attack that we've been seeing. It's something we're calling a data integrity-based attack, which we've witnessed specifically in the context of investigative domains, but we believe is happening much more broadly. What this is it's a way that companies or individuals are exploiting our new reliance on data science and automated reasoning to change the outcomes of those processes to favor decisions that they would prefer. Before I get into the specifics of the talk, I want to thank a lot of the partners we have with this. We've had a 2-year relationship with the World Bank Group, which has provided the bulk of the data that we can actually talk about today. They've been fantastic partners, and this partnership has been made possible through the University of Chicago's Data Science for Social Good Summer Fellowship, where I've served twice as a mentor. It's a fantastic program. They're still taking applications for any students in the room. And it's also been made possible by something that I think everyone's familiar with here, which is this new data deluge. It's the fact that we're collecting more and more information about our environment and trying to use this to reason about the different sectors that we might be doing business in, the individuals we might be doing business with, to build a better picture of our world. Now, of this data we're collecting, estimates are that only about 23% of it is actually useful if we were able to tag and analyze it. But a bigger hurdle we've been running into is our ability to utilize this theoretically useful information. And we're only getting about 1% right now. This means there's a lot of information we could be using to make better decisions, and it's driving us towards the rise of automated reasoning and machine learning. More and more of our processes are being automated. The decisions are being made, at least in part, using these algorithms, and it's exposing us to a vulnerability that we haven't had in the past, or that if we did have, was less severe. And that's the vulnerability that people could exploit this process and exploit what they know about our automated reasoning to direct our decisions towards things that they would like. The primary context I'm going to talk about these attacks through are international procurement with the World Bank Group. If you know anything about the World Bank, what they primarily do is they exist to lend money and expertise to countries seeking to improve their infrastructure. This could be a country wanting to build a road, they could be looking to build schools, they could be looking to build public health facilities, or to provide training and experience to individuals who will staff these schools or public health facilities or other government health organizations. The World Bank provides both money and guidance in the contracting process to try to ensure that the countries end up with something that improves their infrastructure so that we can raise the standard of living globally. The typical way that this process happens is the World Bank works with some country that has an infrastructure project in mind. They lend funds for that specific project to the country, but then the country itself isn't the one that implements those infrastructure improvements. Instead, they work to buy goods and services from various contracting entities. These could be individuals, or they could be companies. And hopefully, they provide then the infrastructure that the money is being lended for. The goal with this is that the suppliers would be chosen through some competitive bidding process, and this competitive bidding process should ensure that the suppliers are both able to provide the services and that they are shepherded through the entire process and actually render the services. But the reality is that the suppliers influence this process, they damage the competitive nature, and they commit collusion, corruption, and fraud. And this results in an enormous amount of waste. We don't know exactly the amount, but the current estimates are that we're only catching about 4% of the actual cases of collusion, corruption, and fraud. The way this manifests is when the World Bank lends money and intends to build some road that might exist for many years, helping to improve infrastructure in the lives of the individuals in the company. Sometimes they end up with a substandard road that doesn't meet the expectations that they had. And other times they end up with no road whatsoever. This is one of the more interesting cases, I think, for us to target, because it's a case where the funds are taken and used for other purposes entirely. Maybe they're being used for bribes, maybe they're being used to buy certain items that have nothing to do with the project, or maybe they're just being pocketed by a company that disappears overnight. And it's a little surprising that this can happen, but what happens is the company will come forward and say, we're a huge company, we have 30,000 engineers, we've done these sorts of projects before, they provide data that backs up these claims, they provide references, and then they don't do the project, or they do it insufficiently. And oftentimes when we go and we look to find these companies later, we don't find a large headquarters in some industrial park. we find a mail slot for which they can accept billing, for which they can accept payment, but there's no one actually home anymore. They've packed up and moved. What's really surprising to me is that this isn't just happening in faraway parts of the world where transparency isn't great. In at least one example, this happened in Chicago. These are companies operating from the United States, representing themselves as experts, and getting away with fraud, collusion, and corruption by damaging this data process. And I think that's something that makes these attacks unique. We're not talking about traditional cybersecurity attacks where we're worried about someone escalating privileges within our systems, making these decisions. We're not really worried about malicious software or potential hardware attacks. We are worried about these things, but it's not the vector that we're seeing. Instead, what we're seeing is a different vector. We're seeing a subversion of the automated reasoning itself, or the machine learning and decision processes, due to malicious manipulation and falsification of data collected through normal channels. The anatomy of attack on data integrity looks almost the same as the anatomy of our normal data collection process. We have some automated reasoning. We have people providing data for us to make decisions. We inspect that data and hopefully come to some conclusion that enhances our objectives. But in the case that the data that we receive is falsified or otherwise manipulated, it compromises the integrity of this process and instead leads to decisions that favor the attackers. There's a lot of different goals that we've seen in the data that we've examined so far for data integrity attacks. One of the most common is identity obfuscation. This is when there's an individual that may have been sanctioned or otherwise has some reason to hide their identity. They find ways to split their records and create a second identity under which they can do business within the actual automated reasoning process. We also see ability misrepresentation, when it's well known what algorithms are being used, or there's some understanding by the attackers of how they're going to be chosen. They can try to design their data so that they look like that magical needle in the haystack that will lead them to be selected by this process. We also see environment misrepresentation. This happens when you have perhaps a normal, healthy market with only a few bad players who then collude or set up front companies to submit a lot of invalid data or data which misrepresents the environment and causes us to make bad decisions because we no longer understand the environment in which we're operating. The strategies that we've witnessed by which companies try to do these attacks, we kind of group into three main areas. The first is data pollution. It's when they flood our databases with large amounts of data, falsified or otherwise, that change our view of the environment. We see a lot of cases of data falsification, where there's misrepresentations of a company's actual identity or a misrepresentation of the way that that company operates, the expertise it has, and reasons to believe them. And the last and most interesting to me is what we're calling data blending. It's when potentially legitimate data is submitted in such a way that it bypasses automated checks and tries to pass by any types of defenses that we might have in place to keep these companies out of the marketplace. To give you an example of an identity obfuscation attack within the World Bank, let's talk a little bit about how the procurement process works. Typically, the World Bank will work with a country to issue a call for suppliers. The suppliers will then submit data on their bids. This will include cost information, expertise, previous work history, and also exactly what they intend to provide. One of them is selected through both automated and human reasoning, and a contract is then awarded. At some point in the future, however, many of these companies will fall under investigation by the World Bank's Vice Presidency of Integrity, who can then void the contract, impose sanctions, and even sometimes debar the companies, preventing them from ever interacting in the marketplace again, or at least bar them from working in it for some time. The identity obfuscation attack is one in which the company tries to then create an alternate identity within the procurement system under which it can now continue to bid despite its sanctioned or debarred status. The debarment's a big deal too because it's not just the World Bank that debars them. When a company is debarred by an international development bank, it's typically debarred at a global level. So how do you do these identity obfuscation? Sadly, in the past, it's been very easy. If you have a company like Acme Incorporated, one of the easiest ways that we've seen that they can create a separate identity which allows them to go through the procurement process would just be to shorten their existing name. Surprisingly, this has worked in the past. And if this isn't enough, I can do something else. I can just misspell my name. That creates an entirely different record that's hard to resolve with my previous history because there's just so much data that we're dealing with. The best thing, too, is some of these attacks, it doesn't even look like an attack. How do I tell that this is malicious and not just a typo? Now, we can see some companies that have history of this, but it is difficult to determine malice in all of these cases. I'm going to show you some real examples with PricewaterhouseCoopers. I don't want to imply that they're in any way malicious. I'm actually picked them because we're pretty sure that they're not. But because they do a lot of great work with the bank, we have a lot of records that we were able to look at and see how well the bank was resolving those. And we found no less than 50 different identities for PricewaterhouseCoopers that have been created through what we think are non-malicious actions, just people typing the name wrong, getting spellings incorrectly, having differences in abbreviation, and differences in white space. Now, we do have some mechanisms that we can use to attack these problems. OpenRefine's a great tool for these syntactic differences. When we have structural similarity between these identities, we can attempt to rectify this and deduplicate information within our databases. But it doesn't always work. What if we just have PwC? Is this PricewaterhouseCoopers? Is it the Pacific Warehousing Company? Is it Porter Walls Company? How do we distinguish between companies and their subnational entities? Should sanctions against the subnational entity apply to the national entity? Should sanctions against the national entity apply to the subnational? This is actually something we can't even get agreement from between the World Bank. The Vice Presidency of Integrity says one thing, Procurement tells us something different, so we're working on context-sensitive resolution in those cases. But it highlights a much bigger problem with these sorts of tools that exist today. They were designed with this assumption that the environments we were dealing in were non-malicious. And this assumption is no longer true. So the tools are ineffective against some of the more sophisticated attacks, even if they protect us from some of these smaller or non-malicious examples. Other vectors which we don't do so well against with tools like OpenRefine or syntactic resolution, reincorporation and legal identity shifts. We've found that companies will oftentimes, after being sanctioned or debarred, change the name that they're operating in. This information isn't always available to us through primary sources because of differences in transparency laws in different countries. We also have cases where a company might create a parent company which takes ownership of them. Sometimes this is legitimate, sometimes it's a way to obfuscate our identity. And beyond identity obfuscation and ability misrepresentation, there's the misrepresentation of the environment itself. We've seen several marketplaces that, at first glance, appear healthy. There's 3 suppliers. They all win roughly even numbers of times. But on closer inspection, we see evidence of turn-taking, where we have collusion between suppliers to make the marketplace look healthy, when in fact they're making sure that the contracts are split evenly amongst them, and they're not delivering on the work. In other cases, we may look at the bidding on a single contract and say, well, the winning bid was somewhat high, but it was a very competitive marketplace. But on further inspection, we find that the losing bids were a little outrageous, making it look like the winning bid wasn't quite so as expensive as it was. And there's a number of lower bids that were all rejected for procedural reasons. They didn't submit a form. They forgot to fill in some important information. They neglected to give us information on their billing accounts, and they were rejected without review. We oftentimes see patterns over time of certain suppliers in a marketplace that have all of their bids rejected. And this is really surprising because having a bid rejected is an expensive process. It costs money to participate. So why would I be participating over a period of 10 years in a marketplace in which I've never even had a bid reviewed? This doesn't make sense financially unless I'm a front company that's helping to damage the view that I have of the underlying environment. Similarly, if we see a company that's never been successful in a marketplace, that keeps submitting losing bids, and these bids are just so terrible that they can't possibly win, we again question whether they're doing this if it's a repeated pattern. And what this is leading us to is a new perspective on how we handle data science and machine learning in these environments. We're now dealing with an adversarial space. We need to find ways that I would argue not only protect our processes, but are proactive in data offense so that we're attacking some of these problems before they actually become an issue. What I want to do is I want to build a community that helps us build intelligent systems so that we can fight data with data. Because just as the adversaries have strategies that they're using to penetrate our systems and take control of our machine learning, we have some strategies we can use too. And we have the advantage of data superiority. We have access to data that our attackers do not. We have the ability to examine all of the data that's being submitted to us, proprietary or otherwise. And we can use a lot of algorithms that have been developed for both syntactic and semantic resolution to improve our ability to understand these systems. We can use the existing syntactic resolution tools like OpenRefine, Levenshtein distance, Ngram analysis to map some of these companies together initially. And even in the cases where structural similarities fail us, there are ways to get at these links that indicate that the identities mean the same thing, even when they are represented completely differently. One of our best ways of resolving these semantic features is to phone a friend. We can actually just ask Google. If I ask Google about international business machines and IBM, even though there's very little structural similarity, Google knows these mean the same thing. There's a crowdsourced database out there for us to mine. We can go and look at the pages that are returned, look at similarities there, and start to build networks. We've also been working with our allies who are building their own databases, like Chris Taggart in London's Open Corporates, where he's been mapping directors and investors between companies. And he's actually been working with us directly to even penetrate some of these markets that aren't as open about this information as we would like. Furthermore, we can mine other expert data systems for these connections. I'm not sure how many people here are aware, but Southwest, ValueJet, and AirTran, all actually the same company. I actually didn't know that before we were looking for some examples we could talk about with this, but Wikipedia knew. There's a high amount of this information in context-sensitive databases, and even if we don't always trust these databases, we have dates and information here that we can corroborate with archival searches on Google News. And so we can try to pull these articles that tell us things like when a company was reincorporated to build these connections. It's not always available. There are some countries where we don't have this information, and so we also learn from the experts. We've been leveraging expert knowledge of the development banks by asking them to help us label data sets to try to identify past cases and look through their investigative caseload to identify when this has happened in the past. Finally, we can leverage our data superiority. We have the best picture of these markets because we can see what work has been done, what bids were submitted, and who was working. And the development banks all work together on a global level. We can look for marketplaces where there was a high amount of contracts awarded to a handful of players. We can examine networks of companies that seem to work together on the same contract. And in fact, the most predictive feature we've found of collusion, corruption, and fraud is the density of other people who have been investigated or sanctioned within your network. We can also look at past histories of individual companies, looking at whether or not they've had risky behavior in the past. Sometimes we find that they're largely participating well in the marketplace with one outlier in this new area that their subsidiary moved into, or cases where we have people with a history of this kind of bad behavior. Leveraging this data superiority gives us a better picture of the network in general and helps us to understand how they interrelate, and these network features have been very predictive. But it's not just about international finance and development. I don't have time today to talk about some of the other cases we've looked at, but we have worked with the EPA, looking at cases where the Toxic Release Act self-reporting guidelines were violated, and there's some evidence that companies were misreporting their data. And with the City of Cincinnati, we've been looking at cases where slum-lords incorporate under multiple names to try to stretch out legal processes when they're violating tenant rights in the city. All this leads us to say that our approach to data has to change, and it has to become adversarial. We need to be designing systems which are made for this sort of adversarial environment. This means a change in our approach so that security and integrity defenses become a design principle. We're working now with the World Bank to leverage this, and we're modifying some of their systems to include syntactic and semantic features as well as these data superiority features to feedback and close this loop with their machine learning outcomes to help them target these companies before they actually commit collusion, corruption, and fraud, and find them in the database before they get away with tarnishing our investigative outcomes. So I'd like to end the talk with a call to action. This isn't really a new area, and I think these attacks have been going on for a long time, but it's an area in need of new focus because of our new reliance on these automated reasoning. I'd like to ask people from industry, academia, and government to help us build a community around this new idea. Help us understand what sectors are currently experiencing this, whether we understand it or not, because I think it's going on in a lot of places that we're not even aware of. And work with other researchers to help design systems that have data integrity as a design principle from the beginning, rather than something we just add on in the end. Thank you very much.